All right, so we are on worksheet 2-1 for our BC calculus, in quotes. There's our new logo. It is in the top right. I don't know why it printed out weird on your guys', like it kind of cut off that line. I'll try to fix that for the future. Let's do number 1. So when I plug in 0, I get 0 minus sine of 0, which is 0. So I get 0 divided by 0. That's indeterminate form. You don't have to check that each time because they are all going to be indeterminate form for this worksheet. So what do? I use L'Hopital's rule. I take the derivative of the top. The derivative of 2x is 2. Derivative of sine is positive cosine. And I saw that minus sign, so cosine of x. And I realized that I'm not being formal yet again because I should be writing the limit. I do want to be formal for these. Limit as x approaches 0 of this thing. And now I can plug in 0. So I can say, yes, now that is going to be equal to down here. 2 minus cosine of 0, which is 1, all over 1, which is equal to 1. Box it. Let's move on to number 2. So I'll plug in 0 and I get 0 divided by 0 yet again. So I'm going to take the derivative of the top and the bottom, derivative of the numerator and denominator. So limit as x approaches 0 is now equal to cosine. I still have 8x, but don't forget to multiply by dinner by 8. That's all going to be divided by 1. Then plug in 0. Cosine of 0 is 1. 1 times 8 is 8. So this is going to be equal to 8. Why do I keep writing equal signs in between? I have no idea. Let's move all that over too. All right. Number 3. Ooh, we have theta instead of x. It's basically the same thing. So tangent of 0. That's impossible. Tangent of 0. What is that? Oh, that's 0. Yeah, because if I'm thinking of the graph of tangent, tangent looks like this function where it goes whoop. So at the x-coordinate, the height is 0. So tangent of 0 is 0. So I get 0 over 0. Then I need to take the derivative. So this is now going to be the limit as theta approaches 0. The derivative of tangent is secant squared. Secant squared of that theta. And the derivative of theta, just like the derivative of x, that's 1. All right, so that's going to be the limit as theta approaches 0. Secant squared is, I'll teach you guys these on the side off here. So secant is the same thing as 1 over cosine, and cosecant, you'll never see it, but just in case you want to know, cosecant is 1 over sine. So this is really asking, what is the limit as theta approaches 0 of 1 over cosine squared of theta? So we can actually plug that in now. Plugging in our 0, that's 1 over cosine of 0 is 1. 1 squared is 1. So our final answer is 1. Let's try number 4. Number 4, I'm plugging in infinity. I get infinity over infinity, also indeterminate form. So let's go ahead and take the derivative. Limit as x approaches infinity. Ooh, I can try writing that infinity slightly neater. Take the derivative of the top, 1. Take the derivative of the bottom. It's still e to the 2x because derivative of e house is e house, but don't forget your dinner, times 2. Why do I keep doing that? Until I do this like 7 times, I'm not going to remember that there's no equal sign. All right, and now that I'm plugging in infinity, it's 1 over infinity, which is just 0. One over infinity is 0. All right, number 5. When I plug in pi over 2, clearly the top is 0, the bottom cosine of pi over 2, that's 90 degrees, that's straight up, and that's the x-coordinate of straight up is 0. Yeah, so 0 over 0. Take the derivative. This is now going to be the limit as x approaches pi over 2 of, okay, the derivative of x is 1, the derivative of a constant is nothing. The derivative of cosine is negative sine of x. Don't have to worry about any dinner because the inner is already x, so dinner is 1. And when I actually take the plug in pi over 2, I get 1 over, okay, so sine of pi over 2, again, I'm thinking on the unit circle. Pi over 2 is straight up, so sine is the y-coordinate. Y-coordinate here is 1, so negative 1. So I have negative 1, and my final answer is negative 1. All right, number 6, I'm getting 0 over 0 yet again, so take the derivative, limit as x approaches 0. This is going to be, the derivative of the top is cosine of 3x. The derivative of the bottom is cosine. Oh, don't forget your dinner. Did you catch it, Era?
Yeah.
Log it. Oh, you don't log them, do you? Cosine of 4x times 4. Don't forget our dinners. Then when I plug in 0, this turns into a 1, so gone. This turns into a 1, gone. It's just really 3/4. Number 7, I'm getting the indeterminate form 0 divided by 0. Let's take the derivative. I now get the limit as x approaches pi of what? So this is going to be just 1 on the top. Because this negative pi, the derivative of that is 0. And on the bottom I get cosine of x. All right, now plug in pi. That's going to be 1 over, okay, cosine of pi. Pi on the unit circle is straight out to the left. Cosine is the x-coordinate. The x-coordinate is negative 1. Therefore, our final answer is negative 1. Number 8. I get the indeterminate form 0 divided by 0, so let's take the derivative of the top. This is now going to be the limit as x approaches 0 of 1 minus cosine of x. On the bottom, I have 3x squared. Oh, that's still not going to work. That's indeterminate form yet again because cosine of 0 is 1. 1 minus 1 is 0, so the top is 0. Bottom is clearly 0 as well because plugging in 0 gives us 0. So take the derivative again. This is now equal to still the limit as x approaches 0. Derivative of 1 is gone. Derivative of cosine is negative sine, but I have a double negative, so it's going to be positive sine of x. On the bottom, I have 6x, and when I plug in 0, I get 0 over 0 again, which means I have to take L'Hopital's rule again. All right, maybe this will be the last time. I'm pretty sure it is. Limit as x approaches 0. Derivative of sine is cosine. Derivative of 6x is 6. And when I plug in 0, cosine of 0 is 1. So this is going to be equal to 1/6. All right, number 9. Lots of e's happening here. When I plug in 0, I get e to the power of 0, that's 1 minus 1 all over 0, so 0 over 0. Not going to work. Let's take the derivative using L'Hopital's rule. Limit as x approaches 0. Taking the derivative of e to the 3x is e to the 3x. Don't forget about your dinner times 3 minus, okay, derivative of e to the 5x is e to the 5x. Don't forget about your dinner times 5 times 5. All divided by the derivative of the bottom is now 1. All right, so when I plug in 0, this is going to be e to the power of 0, which is just 1. E to the power of 0 is 1, so it's really, what is 3 minus 5? That's negative 2. Divided by 1 is negative 2. Number 10. All right, I get infinity over infinity, so that is indeterminate form. Let's take the derivative, still leaving the limit as x approaches infinity out front. Okay, take the derivative of the top. That's going to be 5x to the power of 4. The derivative of the bottom is e to the power of 5x, because same thing. But don't forget about dinner times 5. And I get infinity over infinity yet again. But before we take the derivative, we can cancel out the 5 and the 5. So let's take the derivative again. I get the limit as x approaches infinity. You can try to draw that infinity slightly better. Of that function. So take the derivative. That's now 4x to the power of 3 all over, again, e to the power of 5x times 5 because of chain rule or the dinner. And I get infinity over infinity again. All right, keep going. You're going to have to take the derivative quite a few times here. So this is going to be equal to the limit as x approaches infinity of now 12x squared over e to the 5x times 5 times 5. Why are there two 5s? Well, we had the 1 from back here, and we had to do another 5 down here. And you can kind of see the progression of what's going to happen. Until we get rid of this x, we're always going to have infinity divided by infinity. So if I keep going, so dot, 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 eventually I get 24x over 5 to the power of 3 e to the 5x, then 24 over 5 to the power of 4 e to the 5x. And finally I can say, okay, when I take the limit as I approach infinity, I get some 24 over infinity, so some number over infinity is 0. All right, the last problem that might show up on the test that is for points and not extra credit looks like this. And you might say, hey, I can take the derivative 5 different times, or I could just use magic fraction because that's a magic fraction, and the answer here is just 1/7. But you could use L'Hopital's rule on this one. This one we couldn't use magic fraction in number 10 because, well, I guess you could if you're really smart about it. It would still be kind of hard. Oh, it's not magic fraction though, is it? Because the bottom is a higher degree. Interesting. Okay, number 12 is hard. Because there is no fraction, I guess. Can't even figure out what's going on. If I plug it in though, I get 0 times, okay, natural log of 0. As I approach from the right, I have to put approach from the right because I can't approach from the left. That's outside the domain of natural log. Let's remember what natural log looks like in terms of its function. Natural log looks like this, where it goes through 1 comma 0 there. That means as I get closer and closer to 0, I get closer and closer to negative infinity. So I really have 0 times negative infinity. That is not one of the indeterminate forms that I'm asking for, but it's something that you should know how to do. You can still use L'Hopital's rule to solve this type of problem. I know it doesn't perfectly match with our objective from our notes, but you can use L'Hopital's rule to solve indeterminate form of any type. Well, almost all types. So I'll leave that there. So how do I do this? And the answer is, well, try making a fraction. And you have a 50-50 shot of getting it right. So I'm going to make my fraction. I'm going to randomly choose, I don't know, I'm going to choose natural log of x on the top, and I'm going to choose 1 over x on the bottom. I've done this problem before, so I know this one will work out. The other one will not work out. You'll keep taking the derivative over and over again without making any progress. This one will work out, though. So if I treat it like this, and I guess I should still be writing the limit to be formal about this, I should still be saying the limit as x approaches 0 from the right-hand side, from the positive side of this function. I can also think of this as the limit as x approaches 0 from the positive side of natural log of x, all divided by x to the negative 1, because 1 over x is x to the negative 1. Okay, I haven't even touched L'Hopital's rule yet. I just rewritten x, natural log of x, as natural log of x divided by x to the negative 1. Now I'm going to use L'Hopital's rule. This is now going to be equal to, okay, the derivative of natural log, you guys know, is 1 over x. And the derivative of the bottom, you bring the negative 1 down in front, negative 1. So negative x to the power of negative 2. And I can rewrite this thing as x to the negative 1 over negative x to the negative 2. And you'll notice that some things can cross off. So I can rewrite this again as negative x to the positive 2 over x to the positive 1. And I get rid of one of these powers. So get rid of that power, this whole thing together, get rid of that power. And the answer is negative x. Now when I plug in 0, negative 0 is 0. Again, those will be extra credit on the test.